Hello, welcome to lesson 5 of our logarithm unit. Today we're going to be solving exponential equations. And remember, with exponential equations, in order to solve them, we need to have the same base. So we want to get all same bases. Okay, so taking a look at our first example, we have solve for base 2 to the power x minus 3 equals 8 root 2. So we can see clearly we have a base 2. There's another base 2. So we're going to want to switch that 8 into a base 2. And we know that 8 is the same thing as 2 to the power 3. Okay, so what we have here is our base 2 with x minus 3 equals, so 8 is now 2 to the power 3. And we know that the square root is an exponent of 1/2. Okay, now we work with our exponent laws. We have two base 2's, one with an exponent 3, one with an exponent 1/2, and we know that we add our exponents, so it'll be 2 to the power 3.5, 3 plus 1/2. Now that we're down here, we can forget about our bases, so x minus 3 equals 3.5. We isolate the x by adding 3 to both sides. So the x in this case is 6.5. If you're wondering in terms of logs, let's just make a quick note here. This line really means the log of 2 to x minus 3 is equal to the log of 2 to 3.5. And we know through our log rules, it becomes x minus 3 times log 2 is 3.5 times log 2. And that's where we can also get the x minus 3 equals 3.5. Okay, you don't have to do it the log way. You can choose whatever way you want, but that's just another option. Okay. Number 2, a little bit more difficult. Solve 4 to the power x times 8 to the power x minus 3 equals 1 over 16 to the power 2 minus x. So our smallest base here is 4, but 4 cannot multiply, or so it cannot exponentially go into 8. So the base we're looking for is not going to be 4. So we need to think of a base that, when using exponents, goes into 4, 8, and 16. And that, again, is going to be base 2. Okay, so 4 will be 2 to the power 2 with that exponent outside. The 8 will be 2 to the power 3 with our exponent outside. And 16 is an exponent of 2 to the power 4. Because it's a 1 over fraction, we know that the exponent here is going to be negative. So we actually have negative of 2 minus x. Okay, now we can work with our power law. We stick to the same color here. So 2 squared to the power x is 2 to the power 2x times, over here we're going to distribute the 3 into that. So we have 2 to the power 3x minus 9. And we have 4 times, if I distribute that negative in, so 4 times negative 2, so we have negative 8, and 4 times positive x plus 4x. Great. Now on the left side, it's multiplication law. We can add that in, so we get 2 to the power 5x minus 9 equals 2 to the power 4x minus 8. I'm just rearranging. Now we can work with our 5x, take away 9 equals 4x minus 8. We move the x's to the left to give us 1x. We add the 9 to the right, gives us 1. So the answer here is 1. If you want me to do that step by step, that's okay. So we're going to subtract the 4x from both sides. So we have x minus 9 equals negative 8. Add the 9. And x equals 1. Okay, number 3. So we have 3 to the power x plus 2 minus 3 to the power x equals 72. Okay, we want to see if if 3 can go into 72. 3 times 3 is 9, times 3 is 27, times 3 is 81, so it doesn't work. So what we're going to do is just work with the left side for now. But we know that in exponent rules, there are no subtraction rules. So what happens if you have a minus sign or a plus sign in between your bases? So what we're going to do first is we're going to separate this. This is the finalized answer of a multiplication rule, right? So we can separate it into 3 to the power x times 3 to the power 2 minus 3 to the power x equals 72. Okay, now we have these terms. We have a first term here, and we have the second term here, separated by that negative sign. And we notice from the two of those that we have a common factor. So we're going to commonly factor out 3 to the power x. And when you divide those two terms by 3 to the power x, we get 3 squared minus 1. Okay, 3 squared is 9, so, and 9 minus 1 is 8. Great, so we're still working at isolating that x, so we're going to divide both sides by 8 to get rid of that. Now we have 3 to the power x equals 9, and we know that 9 is the same as 3 squared, so x will equal 2. Okay, so again, if we have a minus sign or a plus sign in between our bases, and you have one of the bases looking like this with two parts in our exponent, we can separate them and hopefully end up with a common denominator, a common factor, sorry. Okay, into word problems. An investment of $2,500 grows at a rate of 4.8% per year, compounded annually. How long will it take for the investment to be worth $4,000? So for this, we work with our compound interest formula, which you learned in grade 11 is going to be A equals P times 1 plus R to the power T. Okay, our P is our principal amount, so how much they're investing, 2,500. The R is the interest rate as a decimal, so 4.8% is 0.048. The time is the years. It's asking us how long, so we don't know that, but we do know the actual amount, and that's what the end amount will be, which is 4,000. So let's plug these into our formula. We get 4,000 equals 2,500 times 1.048 to the power t. Okay, and we've worked with this solving for an exponent before. So let's divide both sides by 2,500. 4,000 divided by 2,500 is 1.6. And when we're looking for an exponent, we use log. So the log of the 1.6 divided by the log of the base, and t will equal 10. So therefore, it will take 10 years. All right. Solve 2 to the power x plus 1 equals 3 to the power x minus 1 to 3 decimal places. Again, different bases, we can't work with them, but we do see that both exponents have 2 different parts. So for the 2 to the power x plus 1, let's change that into 2 to the power x times 2 to the power 1. And for the 3 to the power x minus 1, let's change that into 3 to the power x times, or sorry, it's a minus 1. Yeah, sorry, times 3 to the power negative 1, which is really 1/3. Okay, when we work through this, so this is also written as 1/3. When we work through this, we have 2 to the power x times 2 to the power 1 equals 3 to the power x times, let's just do 1/3. Okay, we're going to multiply this fraction by 3 to get rid of that. We don't like that. But if we're going to multiply that by 3, then we have to multiply the other constant by 3. So we get 2 to the power x times 6 equals 3 to the power x. Okay, we want all the x's on one side, so we're going to divide by 2 to the power x. And that means 6 is equal to 3 to the power x over 2 to the power x. We can break that into 6 is 3 over 2 to the power x. And now we can use logarithms, because now the x is our exponent and it's by itself, it's isolated, so we have the log of 6 divided by the log of 3 over 2, which is 1.5, giving us an answer of 4.419. Okay, last one. Solve 3 to the power 2x minus 10 times 3 to the power x equals negative 9. Okay, first thing we're going to do here is separate that first base of 3, and let's say that it's 3 to the power x to the power 2. Right, our power law is multiply the exponents inside and outside, so we just undid that. And why did we undo that? Because now we can see our brackets, let's move that 9 over, are the same. So now we can let u be the 3 to the power x. So we can replace the brackets with the letter u, and we'll have a quadratic. Okay, so it's simple factoring. The multiples of 9 that add to 10 are 9 and 1, so we have u minus 1, u minus 9. Okay, and if we sub back the 3 to the power x back into this, it really becomes 3 to the power x minus 1 and 3 to the power x minus 9. Now we're going to work with these separately. So the first one here, we have 3 to the power x minus 1 equals 0. So 3 to the power x equals 1, and we know that 1 is the answer when the exponent is 0. So the first x is 0. And now we'll work with the second one. 3 to the power x minus 9 equals 0. So 3 to the power x equals 9. And we know that 9 is 3 squared. So x equals 2. So there's two different options here, 0 and 2. Have a good day.